Section 2.7 Part 2. In this video, we're going to focus on symmetry. First, we'll look at symmetry with respect to an axis. So the graph of an equation is symmetric with respect to the y-axis if when we replace x with negative x, we get the same original equation. The graph of an equation is symmetric with respect to the x-axis if when we replace y with negative y, we get the same exact equation. For this first example, we're going to test and see if y equals x squared plus 4 is symmetric to either the x or the y-axis. Maybe you already know what this graph looks like. It's a quadratic that's been moved up 4, so I know that it's going to reflect across the y-axis, but we're going to need to prove that. So let's start with testing to see if it has y-axis symmetry. So when we do that, we're replacing all the x's that we see with negative x. Notice that I'm putting that in parentheses and leaving the squared on the outside. I know that negative x squared is just a positive x. If we square a negative, we get a positive out. So I end up with the same equation that I started with. Therefore, yes, we do have y-axis symmetry. Now let's test and see if this has x-axis symmetry. So we're going to replace y with negative y, and then we're going to need to solve for y. I'm going to do that by dividing every term by negative 1, and we get y equals negative x squared minus 4, which is not the same as my original function. Therefore, we do not have x-axis symmetry. Okay, let's try it again with this example now. Let's start by testing for x-axis symmetry. So we're going to replace our y with negative y and see if we get the same equation that we started with. We do get the same equation, so yes, we have x-axis symmetry. Now to test y-axis symmetry, we're going to replace x with negative x. And then we see that we do not get the same equation as what we started with, so we do not have y-axis symmetry. Now we're going to talk about symmetry with respect to the origin. So if we have symmetry with respect to the origin, then we have symmetry with respect to both of our axes. So therefore, we're going to do both tests. So if we replace x with negative x and we get the same equation, and then if we also replace y with negative y and we get the same equation, then we have symmetry with respect to the origin. Why don't you pause your video and try this example on your own? So since we're asking if it's symmetric with respect to the origin, you're going to need to test both plugging in negative x for x and plugging in negative y for y 2 separate times and see if they both result in the same original equation. Then restart your video and I'll show my answer. Here are a few quick visuals to help you understand what we're talking about when we're talking about being symmetric to an axis. So this first one, this oblong circle, if we flip it across the x-axis, we're going to get the same graph that we see. If we were to flip it across the y-axis, though, we would have something over here, and it wouldn't be the same as what we started with. Likewise with the quadratic in the middle. We can reflect it across the y-axis, and we get the same thing again. But if we were to reflect it across the x-axis, we would get a whole new function. And with the origin, same idea. If we were to reflect it across both the x and the y-axis, we would end up with the same function that's graphed there.